Okay, I think it's gone. So here is the explanation. I'm going to work through the Hardy-Weinberg practice problems with you, the more Hardy-Weinberg practice. This is on page 107 in our notebook. Okay. So this is, I'm going to show you and walk you through how I want you to be thinking about the questions as you come across them. So we have the original population was hit by a tidal wave. That will come in handy later. 100 organisms were wiped out. Now we have 100 survivors. Out of those 100 survivors, we have 36 are homozygous recessive. So homozygous recessive, we have 36 out of 100. So you can convert that to a decimal, or you can say 36%, right? Either way, I'm going to stick with decimals. My handy dandy calculator. So if you haven't heard, I don't do math in my head. All right, so homozygous recessive is equal to Q squared. So we have that. That was given to us in the problem. So we're done with that one. Now looking at the heterozygotes, this is equal to 2PQ. We have enough information that we can get the heterozygotes. So we don't want Q squared for this one. We only want Q. So if you take the square root, figure out how to work my calculator. If you take the square root, I believe it's 0.6, okay, equals Q equals 0.6, or you can say 60% for Q. We're not here yet, so we have to keep going, okay? So now that we know that Q is 60% of the population has a recessive allele, because that's what Q means. So Q is lowercase a, P is a dominant allele, and we know that P plus Q equals 1, right? So if we know Q is 60%, the other portion of the pie must be 40%. So P equals 40% or 0.4. My pen is acting up, okay? Are we done? No, we're not, because we still need to look at the 2PQ. So you can have 2PQ equals 2. We have our P. I'm going to do decimals because it's easier for me. Okay, so now I need to put this in my handy dandy calculator. And we get the heterozygotes equal 0.48 or 48%, right? So we took what percentage of the population was the recessive allele, what percentage, excuse me, what it has at least one dominant allele, multiply those and times 2. So heterozygotes account for 48% of the population. Sorry, something in my throat. All right, and then this one, homozygous recessive equals little a. All right, and see how I'm putting squares around your answers on the quiz or on a test? Please do that, just because it gets a little messy otherwise. Okay, so now we want to find the homozygous dominant frequency. Homozygous dominant, that means that we're looking for this, which is P squared. Okay, so going up here, we have our P. So 0.40 squared. So once again, there's no shame in using a calculator. All right, so that is equal to 0.16 or 16% of the population are homozygous dominant. So it really comes back to, do you know what each one represents? Do you understand that the genotype, P squared, is very different than just P alone. This is the allele frequency, okay? So for D, given the allele frequencies did change as a result of the tidal wave, we would say that microevolution has occurred because it's on the microscopic scale. There's no big, huge new feature like a beak shape. I keep going back to that, but it's a really good example. There's just a shift in the frequencies. This phenomenon is called genetic drift. Okay? Because they're shifting the allele frequencies. Genetic shift might be. I like that better for my brain. All right, so now number 2. This is the doozy, right? So if 51% of the population carries at least one copy of the recessive allele. So this is where it comes in handy to know what are the different genotypes. It's my camera. That's a little too much. Okay, so here are the 3 different genotypes. What ones could be are carrying one copy of the recessive allele at least? So we need to look at this over here accounts for 51% of the population. So the other part of the population must be the other piece of the pie, which is 49%, right? Because all together, looking at the Hardy-Weinberg equation, we have P squared plus 2PQ plus Q squared equals 100%, or all of the population, because that's all of the options there are for the genotypes. If we had multiple alleles like blood type, you can't use this equation. It's not valid for that, okay? So, moving on up. What is the predicted frequency of individuals in a population that express the dominant phenotype? So we want to find the dominant phenotype. Now this is a little tricky, maybe, because the dominant phenotype could be homozygous dominant, P squared, or heterozygous, 2PQ. So this is the equation that we want to solve for. We have enough information with this because we isolated one genotype. 49% or 0.49 equals P squared. So we need to get P alone. Okay, well, we can plug that one in already, right? We know that one. Now we need to find the heterozygotes. So 0.49 squared, sorry, my nose is drippy. No, I did it the wrong way. The square root of 0.49 rather, to get P alone, equals 0.7 equals P. So knowing P, because P plus 1 equals, or I'm sorry, P plus Q equals 1, here's P. The other part of that would have to be 0.3, that equals Q. We now have enough information to find 2PQ, right? 2PQ equals 2.7, 0.3. So 2PQ equals 0.42. Are we done? No, because we still want to see what percent of the frequency, the percent of the population that shows the dominant phenotype. So we have P squared, homozygous dominant. We have now the heterozygotes. So if you add those together, you end up with 91% of the population shows the dominant phenotype. Okay. So I know there's a lot of steps, but this is what I'm talking about. You need to be able to work your way through the equation with some critical thinking. So you got to slow yourself down enough. Okay, once we have that, this one's easy. What is the predicted frequency of individuals that express the recessive phenotype? Well, we know that there's only dominant or recessive phenotype. We're not looking at genotype, phenotype. So if 91% is dominant phenotype, the other part of the pie is 9%. That makes up the rest of the population with the recessive phenotype. Okay, and that equals all of the population. So what's your answer? The 9%. All right, so I hope this helped. I suggest you do if you're struggling with this, especially number 2, I highly recommend that you do the other worksheets that I put on Google Classroom. And let me know if you have any questions. So just put a comment on Google Classroom. Ask questions. I'm going to do this just in case you're not listening. Ask questions on Google Classroom if you need assistance. Okay, I will peek in as I'm testing to help you.